Our business is the commercialisation of aluminium purification technology.
Solvent extraction is a very unique hydrometallurgical process that almost has sort of scalpel-like precision based on the extractant that you use.
Solvent extraction is not new. It's currently applied to the extraction of lots of metals, but it's not been successfully applied to aluminium until now. Our process is quite elegant and it recycles its reagents into a byproduct that we sell on a 100% basis, further reducing our processing costs. So it's disruptive in that it can deliver very high purity at very low cost.
The future potential for Alpha HPA really is in our flexibility.
It's chemistry based. Materials of construction are relatively basic, so there's not much engineering complexity.
The flexibility of our process flow sheet affords us to be able to meet the ongoing development in technology that's happening in the LED and lithium-ion battery space.
Once we realised the process is capable of purifying aluminium and it's agnostic about where the aluminium comes from, we took a sort of quantum leap in the ability of the business to commercialise, because we effectively can buy our aluminium units as an industrial feed that's not constrained by a mineral deposit or a mining feed.
We've been very fortunate to be able to achieve a robust system for extracting the aluminium, but also a system that's very selective for it.
This is the only alumina SX plant in the world.
We've rapidly evolved the business from pre-feasibility study through building and operating a pilot plant in Brisbane.
Where we can consistently produce, multiple kilograms of product in a week.
And along the way, we're always looking to do things lower cost, more efficiently. And the demonstration plants allowed us to investigate those areas where we can make improvements.
It really comes down to making sure that we understand where impurities are going to deport, make sure that we don't have those impurities coming into our final product.
We begin with feed preparation, where we introduce the aluminium-bearing feedstock to an acidic solution. Here, the feedstock dissolves with virtually no waste, leaving a solution rich in aluminium, ready for ion exchange or IX. This process removes some key impurities, and using special resin beads, traps these impurities while allowing the aluminium to pass through. The resulting solution, known as an eluate, makes its way through to solvent extraction, which consists of three integral parts: extraction, washing and stripping, all of which are required to produce our ultra-pure advanced electrolyte. We start by introducing the eluate to our bespoke organic extractant. The aluminium attaches itself to the organic, leaving all unwanted elements behind in the solution. The organic is then washed with a special solution to further remove any unwanted trace elements. Finally, spent electrolyte is used to strip the aluminium from the aluminium-bearing organic, creating our ultra-pure advanced electrolyte. The organic extractant is sent back to collect more aluminium, and the process repeats in a self-contained loop, with all byproducts that come from the extraction process either sold or recycled. The advanced electrolyte is then cooled to create aluminium salt crystals. The crystals are then decanted and fed into our centrifuge, where any additional solution is largely removed. What remains are aluminium salt crystals that exceed a purity of 99.999%. These crystals are then redissolved and mixed with a catalyst, transforming them into another ultra-high purity compound known as HPA precursor. This is then processed through a filter press, separating it from the solution, resulting in what we refer to as precursor cake. We then feed the HPA precursor cake through a rotary dryer, producing gamma alumina, which then continues through to a calciner where it is converted into our alpha phase high purity alumina. Here it has become alpha HPA with a purity greater than 99.99%. And finally, we jet mill decide our HPA powder to meet the specific needs of our customers. What's most impressive, this process creates no harmful or acidic gases, common in other alumina refining methods. What's essentially a simple but smart process enables us to produce very high purity alumina in the most sustainable way possible.
This facility is going to put us well and truly on the global stage.
We are in a very good position to take the project through to commercialisation.
We are looking to bring roughly 120 operational jobs to the project at full scale, between 300 and 350 construction phase jobs.
And the range of products that will come out of this plant, again, is going to put us on the map.
It would then probably change the way that people look at aluminium worldwide.
The solvent extraction process generates a very high purity aluminium stream. Essentially that stream can then be diverted all the way through to high purity alumina if that's what customers are after. But it can also be diverted into a range of high purity aluminium precursors, which just gives us a lot of commercial flexibility.
We want to try and create value out of every stream that comes out of the plant. Byproducts that come out of the extraction process can all be recycled.
It means that we have a very low environmental footprint. That's not just important in that it translates to a cost advantage, but it's also consistent with the markets that we're delivering into, markets that are driving decarbonisation.
We want to position ourselves to be as adaptable as possible, recognising that as a developing industry.
And that's one of the reasons we've been so successful. We've been able to make progress very quickly to get to where we are today.